Describing functional relationships from graphs, lesson 16 notes. Example number 6. Draw a graph of the function that represents the time and distance Rylan was away from home. This problem is very similar to the train problem that we did in example number 5. Let me read the problem first. Rylan rode his bicycle 1 mile to get from his house to his friend's house. It took him 5 minutes to get there. He stayed at his friend's house for 15 minutes. Then Rylan rode to the coffee shop. It took 15 minutes to get to the coffee shop, which is 3 miles farther away from his home. He stayed at the coffee shop for 5 minutes before riding home. Rylan's ride home took 20 minutes. Okay, so first of all, go ahead and put your distance from home. We have to label our x-axis and our y-axis. This is the y-axis, and the y-axis is our distance from home, which is in miles. And then the x-axis, that's talking about time, which is in minutes. And I went ahead and filled in the grid lines that did not have numbers below it because it's going by 5s. So you can pause your video and fill that in. Okay, so it's important that you pay attention to this problem because you're going to be getting Bellworks 16A, which is just like this. So let's go through and let's highlight the important information. Again, you can just sit and watch. We'll underline stuff in a moment. So Rylan rode his bicycle 1 mile to get to his friend's house, and it took him 5 minutes to go that 1 mile. He stayed at his friend's house for 15 minutes. So he stayed for 15 minutes. Then he rode to the coffee shop. It took 15 minutes to go 3 miles farther. And that's important, the miles farther. He stayed at the coffee shop for 5 minutes. So he stayed for 5 minutes. And then he rode home, and it took him 20 minutes to get home. Okay, so now we're going to go through and we're going to underline this. I cheated. Okay, so under the 1 mile and the 5 minutes that I have highlighted in green, put 1 line. Under the stayed and 15 that I have highlighted in purple, put a squiggly line. For the 15 minutes and the 3 miles farther, put a box around it. For the stayed and the 5 minutes, put an oval around it. And then the home and the 20 that's highlighted in orange, put 2 lines under it. Okay, so before Rylan gets started, he's at home. So if he's at home, how far is he from home? 0 miles, because he's at home. At home means he's 0 miles from home. And he hasn't left yet, so then there's no time. So that's why the first point is at 0, 0. He took 5 minutes to go 1 mile. 5 minutes to go 1 mile. So go over 5 minutes and up to 1 mile and put a point. So over 5 minutes and up to 1 mile and put a point. That's when he's at his friend's house. He stays at his friend's house for 15 minutes. Remember, if it's staying, he's constant. So he's 1 mile away for 15 minutes. So from this point right here, I want to go over 15 minutes. 1, 2, 3, so that'd be 5, 10, 15. So right here would be 15 minutes. 5 minutes, 10 minutes, 15 minutes. So then he leaves his friend's house and he goes to the coffee shop. It took 15 minutes to get to the coffee shop, which is 3 miles farther. Now this is the key. He is already 1 mile from home. Now he goes 3 miles farther. It's not that he's 3 miles away from home. He's 3 miles farther away from where he already was. So you have to take the 1 mile that he's already away and go an additional 3 miles. So 1 plus 3 would be 4. So that means in 15 minutes, he was 4 miles away. So go over 15 minutes and up to 4 miles. Over 15 and up to 4 miles. He stays at the coffee shop for 5 minutes. He stayed for 5 minutes. So he's 4 miles away for 5 minutes. So we'll put a point there. And then he rode home. Well, to get home, he's back to 0 miles from home. And it took him 20 minutes to get there. So I'm going to go over 20 minutes and down to 0. Over 20 minutes and down to 0. Now that we have the points on our graph, we're going to go ahead and connect them. Make sure your lines are straight. And that's Ryland's bicycle ride. If you have any questions, let me know.